We are saying less than 1. The function will be decreasing. For it to decrease, the exponent has to be positive. The exponent must be less than, or must be positive. For the function will be decreasing here if a is less than 1, but the exponent has to be positive. The exponent has to be positive. Let's look. If we have 2 over 3 exponent x, the exponent is positive, and also here we are having the value of a less than 1. This will be a decreasing function. Here, if for instance we have 4 over 3 exponent x, this value is greater than 1 and the exponent is positive. Therefore, the function will be increasing. So, remember we started by saying if a is greater than 1 and the exponent is positive, the function will be increasing. But if a is greater than 1 and the exponent is negative. A is greater than 1 but the exponent is negative. This is a decreasing function. Decreasing function. So this is the same as when we are having 2. Exponent is less than 0. Exponent negative x. This as a function, it will be decreasing. This will be a decreasing function. Remember, a is greater than 1, but the exponent is negative. That's a decreasing function. A is less than 1, but the exponent is positive. That will be a decreasing function. Right, let's continue. Right, so we set our asymptote here. Our asymptote, which is a horizontal asymptote, y is equal to 0. Our y-intercept, we've got our y-intercept, which is 0 is to 0. Now I want to shift this graph. If we are to shift it, it will be looking as a exponent x plus q. Let's say minus. X minus q plus p. Right. So it's either you move to the left or to the right. We said x is an element of real numbers. You can't block this from moving either to the right or to the left. There will be no asymptote. Let's look now. If we are to let y to be p, if our y is p, we are going to have x minus q plus p. We are making our y to be p. we are to solve for x. A exponent x minus q is equal to, when you transpose p to that side, it will be 0. So when you look here, this will no longer exist. We can't equate an exponential equation to 0. It will no longer exist, which means y must not be equal to p for this to exist. That's a restriction. Y must not be equal to p, because once y is p, we are going to find 0 there. That will make our graph not to exist, which means y is equal to this value will make our graph not to exist. Y is equal to p is our horizontal asymptote. Our horizontal asymptote. It's our horizontal asymptote. We do not have a vertical asymptote in an exponential function. Right, let's look at this function here. H of x is equal to 2 exponent x minus 2 plus 1. Right, now we have translated our graph. At first, it was f at x equals 2x. Remember, if it's x minus 2, we have shifted this graph 2 units. It's x minus 2. Let's solve for x here. X is equal to 2, which means we have shifted this graph 2 units towards the positive values of x. We have shifted this graph 2 units to the right. So in our y again, we are adding 1. That means we also shift this graph 2 units up. So the graph of f to produce h, it shifted 2 units to the right, 1 unit up. That's the translation that took place here. And then in terms of the asymptote, if we are to make h to be equal to 1, transposing 1 to this side, it will give us 0, which means our horizontal asymptote here, asymptote y is equal to 1 is that value. Therefore, in this case here, P is our horizontal asymptote. Remember, we are adding something to y. When you are to add here, that means you are going up. When you subtract, you go down. Therefore, P here is the vertical shift. P is the vertical shift. It's a vertical shift. P is the horizontal asymptote, which is our vertical shift. What is Q? Q is our horizontal shift. We are adding or subtracting something to x, to our x. That's a horizontal shift. That's a horizontal shift. Right. In our graphs that we've sketched, our y-intercept was there for both increasing and decreasing function before shift. Our y-intercept is at this point. That's our y-intercept. But here, after you shift the graph, it's either downward or upward. We've added 1 there. So we are shifting the graph upward. That means this graph will move from 1 to that point. So once it moves from 1 to that point, this means that our x-axis are shifting to 1. When you shift the graph, it's either you shift the y-axis or the x-axis. Now our asymptote will be there. This is our asymptote, which is equal to 1. It's 1. So now our graph is there. Y is equal to 2 exponent x plus 1. So for y-intercept, we let x to be 0. 2 exponent 0 is 1, 1 plus 1 is 2. That's why our y-intercept will be there. It's an increasing function, therefore it goes like that. It is increasing, but our y-intercept is no longer at 1 because this graph shifted 1 unit up. It's now at 2. Right. So we are saying it's an increasing function. It's either increasing or decreasing, right? When do this graph start to increase? It increases above 1. It increases above 1 or it decreases above 1 if it's decreasing. Therefore, that means our range, for the range, you just look at this value, the value of q. Our range, y can be any value, but that value must be above 1 for this graph to exist. That value has to be above 1. It has to be greater than 1. Remember, above 1, this is an asymptote. That means y must not be equal to 1 because the graph won't exist. You can't say your range y greater or equal to 1. No, it's y greater than 1. Y must be above 1 for the graph to exist. Same as if you are having this graph where our y-intercept is there. So in this case, let's say this is the function of g. In this case, our range for this graph to exist, it has to be above the x-axis here. That means our range, y is an element of real numbers, but y must be above the x-axis. Y must be above the x-axis, not below. Because once you say below, that means it will touches the x-axis and go below that. So while we are still there, for the domain, X is an element of real numbers, domain. And then for the range, without even sketching the graph, you just go to the value of P. Y is an element of real numbers, but those values of Y must be above 2 for this graph to exist. So Y must be greater than 2. Y must be greater than 2 for the graph to exist. You just look at the value of Q. So to sketch an exponential equation, you just find x and y intercept and then the other 2 points. So you sketch the graph. And be careful of the shape of the graph. Be careful of the shape of the graph. Right. G at x is equal to 2 exponent x plus 1 plus 1. So this means that this graph shifted 1 unit up and 1 unit. We said plus 1, so it's 1 unit to the left. Therefore, I want us to sketch the graph of h. The graph of h will be produced by shifting g 1 unit to the right, 1 unit down to form the graph of h. Shift the graph of g 1 unit to the right, 1 unit down. This means that in the graph of g, g will be equal to x minus 1. Remember, when you are shifting to the right, we say minus 1. It's minus 1. You are shifting 1 unit to the right. And 1 unit down. So we subtract 1 in the graph of g to form the graph of h. Let's see. So this means that in the place of x, we put x minus 1. So it's 2. In the place of x, it's x minus 1. And then there is that plus 1 there. It's plus 1. Plus that 1. Remember, in the graph of g, we subtract 1 because we are shifting downward. That's minus 1. So the function of h now will be given by 1 minus 1, it's 0. Therefore, it's 2 exponent x. 1 minus 1 is 0. So that's the new equation. So to sketch this graph, obvious, it's an increasing one. It will be looking like that. That's the function of h. With 0 is to 1. So that's how to shift the graph. That's how to shift the graph. We shift at this graph 1 unit to the right, that means we are subtracting. And then 1 unit down, again we are subtracting. Right, let us reflect the graph. Reflection. we are reflecting an exponential function, right? H at x is equal to 2x. We are to reflect. We are to reflect. Remember, we had this function, which is an increasing function. Our y there is positive. And again, if this graph is decreasing, it comes from that direction. Right. Again, y is positive there. Right, if you are to reflect this, about the x-axis, reflecting about the x-axis, we've got 0 is to 1 here. Right, so if you are to reflect this, remember, we multiply, since we are reflecting about the x-axis. We are reflecting about the x-axis. Y is positive here. So once you reflect, you go to the negative values because you are reflecting about the x-axis. So we multiply any value of y by negative in this graph, which means since we are having 0 is to 1, the y-intercept will change to be 0 is to negative 1. It will change to be 0 is to negative 1. Right, I just want to check what will happen after reflection. Is the graph going to increase or decrease? We are reflecting about this. After reflection, this graph, we are reflecting this graph. After reflection, we are reflecting this about the x-axis. About x-axis. Which means we are going to multiply the whole equation by negative. Let's say it form the graph of G. So this will be negative 2. Exponent x. We multiply everything there by negative. Because once you reflect about the x-axis, y will be affected. Right. Sketching this graph. Right. Negative 2, exponent negative 2, that will be negative 4. Negative 2, exponent negative 2, that will be negative 1 over 4. Putting negative 1 there, it's negative 1 over 2. Putting 0, it's 1. Putting 1 up there, it's negative 2. When you are to put 1 there, let's sketch the graph.
This is negative 1.
Right, we just want to check if it will be increasing or decreasing. It's negative 1, negative 2. Right, let's sketch the graph. If x is equal to -2, y is equal to -1/4. X is equal to -2, y is equal to -1/4. It's a quarter. It's a quarter. Let's write 2 there. That's our point. -1 is to -1/2. That's half. So the point will be there. 0 is to -1. There it is, our y-intercept. 1 is to -2. There is the point. 2 is to -4. Right, somewhere there. Right, remember, this graph is from here. But after reflection, it looks like that. So here we were having -2 is to 1/4. -1 is to 1/2. 0 is to 1. 1 is to 2, and so on. Same as here. Here we are having 1 is to -2. 2 is to -4. And then here, -1 is to -1/2. Right, all these points. 2 is to 4. When you look here, we have just multiplied the values of y by negative. We had 1/4, whereas here, now we are having -2 is to -1/4. After reflection, you just multiply the values of y by negative if you are reflecting about the x-axis. Looking at our graph, here it's an increasing function. It's an increasing function, this graph of h. After reflection, it forms the graph of g. The graph of g. The graph of g, let's look. It's -2. Y is equal to -1/4. So when we look at the values of y, they are decreasing, whereas x is increasing. Therefore, after reflection, this graph will be a decreasing function. It's a decreasing function. It will be a decreasing function after reflection. Once you reflect about this line, it will be a decreasing function. Let us now reflect about the y-axis. Remember that when we reflect about a horizontal line, x is affected. When we reflect about a vertical line, x will be affected. X will be affected. We are having this as an increasing function, a function of h. -1, -2, it's 1, 2. Right. So this point here, 1 is to 2, this will be 2:4. And then here, -1. -1 is to 1/2. And then -2 is to 1/4. We are reflecting about the y-axis. When you reflect about the y-axis, you just multiply x by negative. You multiply x by negative after reflection. So you just multiply x, it will be negative x after reflection. You multiply the values of x there by negative. Let's check. Remember, y won't be affected. Only x will be affected. Right? We multiply this by negative. So it will be positive 2. It's 2, 1, 0, -1, -2. Remember, y is not affected. Our y is still 1/4. 1/4, 1/2, 1, it's 2, it's 4. After reflection. So, when you look here, our y, no, we have changed the points. It mustn't be like this because y is not affected. Y must be as it is. So we've got that. After reflection, let's draw the table, the complete table. It's g at x is equal to 2 exponent minus x. We are reflecting about that. Right, its x is to y. So if we put -2 there, it's 1/4.